Hello my dear students, good morning to all of you. In today's session, we are going to discuss on a very important topic, that is Townsend's current growth in the presence of what? Secondary ionization processes. Okay. In the previous class, we already discussed about the various ionization processes, right? What are the types of ionization processes? One, it is ionization by collision process, and the second one is photoionization process, and third one is secondary ionization process, and fourth one is electron attachment process, right? So, by considering now what we are considering, secondary ionization processes. By considering these secondary ionization process, what we are going to study now, how the current growth which is occurs in the presence of what? Dielectric media which is present between the two electrodes. That can be well explained with the help of the one of the most famous scientist, that is Townsend. Okay. So let us start with I think all of you familiar with the secondary ionization processes. So what are the types of secondary ionization processes? How the electron it is going to be gets emitted from the cathode. So there are three types are there. Which are those? Okay, let us start with the session now. See here, as we know that the secondary ionization processes, see here. So as we know that the secondary ionization processes is mainly due to the following reasons. Which are those reasons? The first thing is electrons gets emitted from the cathode due to the effect of what? Positive ions, that we already discussed, right? So second one is electron emission due to the photons. Photons, it is nothing but the packet of energy. This energy which is going to be incident on the cathode by incidenting which rays? Ultraviolet radiation on the cathode. Due to this light energy, how the electrons are going to be gets emitted. Those electrons are going to be called it as a secondary electrons. Due to this secondary electrons only, the ionization process has takes place in the two electrode system. Okay, so that is also electron emission due to photons. Then third one is electron emission due to the metastable and the neutral atoms. Go through the previous videos or previous sessions what we have covered. In that we already discussed about the secondary ionization processes. So there are three reasons. Which are those? One, it is electron emission due to positive ion impact, and the second one is electron emission due to the photons, nothing but the light energy, and the third one is electron emission due to metastable and the neutral atoms. Okay, metastable, it is nothing but what I told. Metastable atom, it is nothing but the excited particle, nothing but this is the lifetime of these kinds of particles. It will be very huge itself, or it will be very high. That is of order what? 10 raised to minus 3 seconds when we compare with the ordinary particles. So those ordinary particles lifetime will be of a 10 raised to minus 8 second. Keep it in mind. Metastable atom, it is nothing but excited atom whose lifetime is more, that is of order 10 raised to minus 3 seconds. Okay. Neutral atom, it is nothing but the ground state atom. Is it right? So due to this neutral atom incidenting on the cathode, so the electrons are going to be gets emitted. Those are going to be called it as a secondary electrons. Okay. So these are the three reasons the secondary ionization process has takes place between the two electrode system. Okay. Now as in the previous class we have discussed on the Townsend's current growth equation. What we consider? By considering the primary ionization process. Okay. So what the equation we got in the previous class, you just go through the previous derivation. We have got the equation for the amount of current, the current calculation. So due to the huge amount of the current, the breakdown of the dielectric medium takes place. Is it right? So the how much amount of the current, the calculation it has been done with the help of the Townsend's current growth equation. Okay. In the previous class class we have derived. So that equation only I have taken here. So I is equal to what? I naught exponential of alpha into d, and this is the amount of current growth. And what about number of electrons? Nd, it is nothing but the number of electrons which are emitted at a distance of a d between the two electrodes. This will be equal to n naught exponential of alpha into d. So these two equation in previous derivation we have done, just to go through those, okay. Where alpha it is going to be considered as what? Alpha is the Townsend's primary ionization coefficient. Keep it in mind. So now we are studying about the current growth in the presence of the secondary ionization processes. But the alpha it is going to be considered as a primary ionization coefficient. Then what about secondary ionization coefficient? That will be represented with the help of a symbol, that is gamma. So these two representations are very important. Alpha it is the primary Townsend's primary ionization coefficient. Gamma is what? The secondary Townsend's secondary ionization coefficient. Keep it in mind. Don't get confused with the abbreviations, okay. So next thing here, the electrons which are produced by the above mentioned processes. Which are those processes? The emission due to the positive ion impact, or electron emission due to photons, or electron emission due to the metastable and neutral atoms. These are the processes, right? Due to the impact of these atoms on the cathode, the electrons are going to be gets emitted. So those electrons are going to be called it as what? Secondary electrons, okay. So now the secondary ionization coefficient, that is represented by what? Gamma. What is alpha now? Alpha it is the Townsend's primary ionization coefficient. Then now how will define this gamma? Gamma it is nothing but it is defined in the same way as that of the alpha only, but it is the sum of net number of electrons which are produced per incident positive ion, as well as the photon, as well as metastable particles and the neutral atoms. Getting my point? So don't get confused. Gamma it is nothing but the secondary ionization coefficient. So this will be the sum of what? The electrons which are emitted due to the positive ions, electron emitted due to the photons, and the electron emission due to the metastable and neutral atoms. Getting my point? So all together, sum of all together, it will give the secondary ionization coefficient. It is represented with the help of a symbol, that is going to be called it as a gamma, okay. The total value, that only I had represented with the help of the equation here. So gamma is nothing but the secondary ionization coefficient, gamma 1 plus gamma 2 plus gamma 3. What it represents? Gamma 1 it is nothing but the electron emission due to the impact of positive ion, and gamma 2 is the electron emission due to the photons, and gamma 3 is the electron emission due to metastable and the neutral atoms. The sum of all together, it will give the secondary ionization coefficient. Keep it in mind, okay. I hope this is clear to all of you, okay. So that only I had represented here. Gamma is the Townsend's secondary ionization coefficient, which is almost similar to that of the alpha also. In the previous derivation, I told that alpha is the Townsend's primary ionization coefficient. That is also depends upon the two factors, or we can say that alpha it is also the function of two factors. So here in this case also same, the secondary ionization coefficient, that is gamma, it is also the function of what? Which are those two factors? The first one is gas pressure. Where the gaseous medium will be present, we had considered the two electrode systems, right? The in between the two electrode system, there is a small distance. That distance it is covered with the which medium? That is gaseous medium. Okay, getting my point? So that gas pressure will determines this gamma. Am I getting my point? So this is secondary ionization coefficient. It will be the function of which are the two factors, which are those? One, it is gas pressure, and the second one is the ratio of applied electric field to the gas pressure. Keep it in mind. I hope this is clear to all of you. Next we'll move on to, let us start the derivation now. Okay. So first initially let us assume that N naught dash. In the previous derivation, I had considered the N naught electrons are emitted from the cathode I had taken. But here, so just for the sake of representation, differentiation purpose, N naught dash I had done, because these many number of electrons are which are produced due to which process? Secondary processes. Secondary processes means which are those? Electron emission due to positive ion impact, or electron emission due to the photons, or the electron emission due to metastable and the neutral atoms. Getting my point? N naught dash represents what? Number of secondary electrons which are produced due to the secondary processes. Don't get confused with the representations. Okay. So now let us consider N naught double dash. N naught double dash, it is nothing but the total number of electrons which are leaving from this cathode. Nothing but due to the impact of the positive ions, or due to the impact of photons, or due to the metastable atoms, the electrons are going to be starts living or emitting from the where? From the cathode itself. Is it right? So that I will represent it with the help of what? N naught double dash. Okay. Then so we can say that the total number of electrons leaving the cathode, this will be given by N naught double dash equal to N naught, it is nothing but what? That is the number of electrons emitted, that is primary ionization process, right? N naught plus secondary ionization process, number of electrons are emitted. So this is nothing but all together it will give the how many number of electrons which are leaving from the cathode will come to know. Is it right? N naught double dash is equal to, N naught is nothing but the number of electrons emitted from the cathode due to which process? Primary ionization process. And this is what about this one? The number of electrons which are produced due to the secondary processes. This is due to the primary and this is due to the secondary process. Both together it will give the total number of electrons which are leaving the cathode. Okay. So, okay, call this equation as a 1. So next we'll move on. Total number of electrons. Once the electron starts moving from the cathode, then it should reach the anode, right? The total number of electrons reaching to the anode, that will be represented by only N here. Don't get confused with the representations. Okay. Number of electrons reaching to the anode, it will be represented by a small n here. So I can write from in the previous class derivation we have done here. So that I can write it as a number of electron reaching to the anode, n will be equal to. So these many number of electrons leaving from the cathode, then it should reach to the anode, right? So that I will take it as a n naught double dash exponential of alpha into d here. So getting my point? So here this n is equal to, n naught double dash means what? So this will be equal to n naught plus n naught dash. That only I had substituted here instead of this n naught double dash. N naught plus n naught dash exponential of alpha into d here. Call this equation as a 3. Next. So here, and the number of electrons releasing to the gaseous medium. How what it is in between the two electrode system. Let us consider the diagram now just for the sake of clarification purpose. Here the two electrode system it is there. Is it right? This is the anode and this means positive, and this is the cathode and this is negative here. Between these two electrode gaseous medium will be present, right? So here, so first initially n naught electrons, once we give the supply, how many electrons are going to be starts moving from cathode to anode. Will you agree for this one? Is it right? So now initially we don't know how many number of electrons are going to be emitting from this cathode. That I had considered as a n naught. Getting my point? Next what I had considered, n naught dash. N naught dash, it is nothing but the number of electrons which are emitted from the cathode due to the impact of the photons, or nothing but the secondary ionization processes, that is represented by n naught dash. Getting my point? Then after this, these electrons should reach the anode, right? The number of electrons which is reaching to this anode, I will represent it by how? Only small n itself. Is it right? So, next thing it is, in between this gaseous medium, how we will calculate how many number of electrons are going to be released in this gaseous medium. So, just traveling towards the anode, whatever the representations we have done. But here in this gaseous medium, that I will write like this. See here, the number of electrons releasing to the gaseous medium. How will write this one? Nothing but completely reaching to the anode, n I have taken here, minus n naught plus n naught dash. Getting my point here? N naught is the initial number of electrons due to the primary ionization process. N naught dash is the due to the secondary ionization process. When we subtract from this how many number of electrons reaching to the anode means, this will give the number of electrons which are released in the gaseous medium. Don't get confused. So, this will be n minus into the bracket of n naught plus n naught dash. Okay. Next here. So, what I told here? So, assuming each positive ion, due to the impact of the positive ion, the electrons are going to be gets emitted, right? Assuming each positive ion which is releasing from the effect of the positive ion. So, that will be represented by gamma. Is it right? Assuming each positive ion releasing the gamma effective electrons from the cathode. Then how will write this one? N naught dash is nothing but what? The number of electrons are going to be released due to the secondary processes. Okay. This will be equal to how many number of due to the positive ions, how many effective electrons are going to be releasing from the cathode, that is gamma. So, gamma into the this one, and then it reaches to the anode. From cathode, these many number of ions due to the positive ion, gamma number of electrons are going to be releasing, then it should reach to the anode, right? So, that product will give the number of electrons which are emitted or released due to the secondary processes. Okay. N naught dash is equal to gamma number of electrons which are releasing from the cathode, gamma I had taken here, then it should reach anode, right? Then reaching to the anode, how many electrons are there? This I had represented here. So, n into the bracket of n minus into the bracket of n naught plus n naught dash. So, this will give the positive ions which are releasing from the cathode. Okay. Just to simplify this equation now, n naught dash equal to gamma into the bracket of n minus n naught plus into minus, it will be minus only, minus n naught dash here. So, this simplification I am doing here. Then now n naught dash equal to multiply with gamma inside here, gamma n minus gamma n naught minus gamma n naught dash. Okay. Now what I had taken here, what are the common terms are there here? This is the LHS side there, this is the RHS side there. Here N naught dash is there, here also N naught dash is there. So, shall I take this to the LHS side now? N naught dash plus gamma N naught dash equal to gamma N minus gamma N naught. Okay. Now, what I can take common here? So, I can take the N naught dash, is it right? N naught dash is equal to into the bracket of 1 plus gamma. This will be equal to, what is the common here? Gamma. I can take, right? So, gamma into the bracket of N minus N naught. Okay. From this equation, I can write now N naught dash is equal to, how will write N naught dash? This will be gamma into the bracket of n minus n naught divided by 1 plus gamma. This is the equation for what it is. N naught dash means what? So, n naught dash is the number of secondary electrons are produced due to the secondary processes. Keep it in mind. If somebody has asked means what are the secondary ionization processes means, which are those? There are 3 processes are there. Electron emission due to positive ion impact, and the second one is electron emission due to the photons, and third one is electron emission due to metastable and the neutral atoms. I hope this is clear to all of you. Okay, we got the equation for what now? That is number of secondary electrons which are produced due to secondary processes. Okay, let us move on now. Now what I will do, substitute the equation number 4 in 3. What is the equation number 4 is there? So this is the equation number 4, and where I am going to substitute now? In this equation number 3 here. Instead of this n naught dash, I will substitute the value for this n naught dash in the equation 3 here. So I can write now, so n is equal to into the bracket of n naught plus, so instead of the n naught dash, I am substituting this one, gamma into the bracket of n minus n naught divided by 1 plus gamma into what is the remaining term is there? Exponential of alpha into d. Okay. So now simplify this equation. How will simplify? What is the LHS of this equation? 1 plus gamma is there. Is it right? N is equal to 1 plus gamma. This is the LHS. Then how will write? N naught into, here multiply we have to do, right? N naught into the bracket of 1 plus gamma plus gamma into the bracket of n minus n naught here, and the remaining terms as it is I had written here. Then you do the simplification here. What you will get now? So when we multiply inside this one, n naught plus n naught gamma plus gamma n minus gamma n naught. What is the same common terms here? N naught gamma, here also there, gamma n naught is there. We can cancel both each other, right? So we can cancel these two, and what is the remaining terms are there? I had written here. Okay, n is equal to n naught plus gamma n divided by 1 plus gamma into exponential of alpha into d here. Getting my point? So next here, next what I had written here, so this 1 plus gamma I had taken, where I had taken here? To the LHS side. So n into 1 plus gamma, this will be equal to what? N naught plus gamma n into the bracket of exponential of alpha into d here. Just you do this, just a very simple simplification is there. When multiply inside this n, then what you will get here? N plus n gamma. So this is equal to n naught exponential of alpha into d plus gamma n exponential of alpha into d, right? So now what I had taken here? Here also gamma n is there, here also gamma n is there. Shall I take this to the LHS side? Is it right? So n plus n gamma minus of this one, gamma n exponential of alpha d. This is equals to, what is the remaining term in the RHS side? So n naught exponential into alpha into d here. Is it right? I think you are getting the very simple simplification, it is there. Okay. So now, so how will do this one? I can take, what the common I can take here in these three terms? Anybody can tell here? So that is only n, right? So n I had taken common here. Inside what I had written? 1 plus gamma minus gamma exponential of alpha into d. This is equal to what? N naught exponential of alpha into d here. Getting my point? What is the common I had taken here? N I had taken common. So I can write the equation for n now. What is the representation for n? What it will represent? N means what? N, it is nothing but the number of electrons reaching to the anode. Is it right? So next here. Okay. So n equal to, I can write the equation now, n naught exponential of alpha into d divided by 1 plus alpha minus alpha exponential of alpha into d. Okay. Getting this one? So what, anything else what I had done in this equation? N is equal to, as it is in the numerator, as it is I had written, n naught exponential of alpha into d divided by 1 plus, here what I can take the common here? Gamma is there, here also gamma is there. I can take this common, right? So I had taken the gamma outside, and inside what you will get? 1 minus exponential of alpha into d here. Is it right? So anybody is having confusions with this one? I think no. Okay. Here n is equal to n naught exponential of alpha into d. I can rewrite like this also. Is it right? So 1 minus, this term I had interchanged here, means obviously outside will be negative here, is it right? 1 minus gamma into the bracket of exponential of alpha d minus 1 it is. So this will give the number of electrons which are reaching to the anode. So how many number of electrons which are reaching to this anode, how we can calculate? By using this equation we come to know how many number of electrons which are reaching to the anode. Getting my point? Then what about current? Current, it is nothing but the movement of electrons, right? So these many number of electrons which are moving to the anode means by this equation we can calculate the movement of electrons. It is nothing but the current growth, is it right? Current, it is, what is the definition of current? Nothing but movement of electrons, right? So now, so here we can write the equation for current now. So instead of this number of electrons movement, I have taken the current here, I, this will be equal to I naught exponential of alpha into d and divided by 1 minus gamma into the bracket of exponential of alpha into d minus 1 itself. So this is going to be called it as what? Townsend's current growth equation. By considering which processes? Secondary ionization processes. Which are those secondary ionization processes? There are 3 processes are there. Which are those? One, it is electron emission due to positive ion impact, and the second one is electron emission due to the photons, and third one is electron emission due to the metastable and the neutral atoms. I think this is clear to all of you. This derivation is very important from exam point of view. Just you have to concentrate more on this one. So just you go through. And this is the diagram what I had considered for the, just for the sake of a reference here. I hope this derivation, it is clear to all of you. Okay. Thank you.